Hello student, good morning. A warm welcome to the database management systems second session. So in the second session, we are going to start with the new topic. The topic for us for the second session is relational integrity. In this topic, we are going to see some constraint in the relational integrity. So relational integrity constraint is used to ensure the accuracy and consistency of data in relational database. Whenever we need to manage this, the accuracy and consistency, at that time, we need to maintain the relational, or we have to take care, use, or that can be taken care by relational integrity. So the term relational stems from the fact that each table in the database contains information related to single subject and only that subject. So whatever the information is available in our database is related with that particular subject is also can be taken care by this relational integrity. So following are the some integrity constraints. First one is integrity constraints are a set of rules. What is this relational integrity? So it is some set of rules. So there are certain rules are available. It is used to maintain the quality of the information. Whenever we need to maintain the quality of the information or the proper information over there, at that time, integrity constraint need to get followed. It ensures that the data insertion, updation, and the process have to be performed in such a way that data integrity is not affected. Whenever we need to do any operation on our database, at that time, we need to do a such a way that the integrity is not affected. It is used to guard against the accidental damage of the database. So it can be act as a guard. Whenever it may possible during the perform of particular operation on the database, some of the data may get damaged. It may get possible. So to avoid these all things, integrity constraint can take care for the same. It is called as the relational integrity. We will see in the detail as there are certain types of the relational integrity. So these are domain constraint, entity integrity constraint, referential integrity constraint, and key constraint. So these are the various type of the integrity constraint. Now we need to see what is in my domain in constraint, what is the entity constraint, what is it referential or referential integrity constraint, and key constraint. So in the domain constraint, what is going to be happen? So here it is explained with respect to a particular table. That table can be act as a database. So database is given over here. So we need to use that one. So in the domain constraint, it defines the valid set of the values for an attribute. The data type of the domain includes either string, character, integer, time, data, currency, etc. We have seen this thing during the implementation of our database. So we have already seen how we are going to implement our database for the student information, either for the bank related purpose. So whenever we need to implement that, at that time domain can be string, character, varchar, integer, time, date, and currency, etc. So there are various, we can say, domains are available. So the value of the attribute must be available in the corresponding domain. So we also need to check the proper value should be available. For example, a particular attribute of particular in a particular table, there may be certain attributes. One of the example is given over here. So there is a table having the attribute ID, name, semester, and age. Can we consider a ID number 1000 at that time? That particular ID having the name Tom, or we can say Tom having the ID 1000. He is in the first semester and his age becomes 17. So ID is integer type, name is string type, semester is, it may be the integer, then age is again integer. But if we are going to see towards ID number 1004 having name Morgan, he is in the 8th semester, but his age A is mentioned over here. This is not allowed. Why? Because age is in integer type. So their value at their place should be an integer. It is called as the domain constraint. So you can't put any other value in the particular domain. So it is called as the domain constraint. So particular value should be available in the particular attribute, and attribute having different data types. So data types are string, character, varchar, integer, time, date, and currency. So there are number of the data types are available. Entity integrity constraint. What is happen in the entity integrity? So it states that the primary key value can't be null. So whenever we are going to assign a particular attribute as a primary key, at that time primary key should not be null, because the primary key value is used to identify individual row in relation. So that primary keys plays an important role to find the particular row in the relation. So if the primary key has a null value, then we can't identify those rows. If primary key having the null value, it will be very difficult for us to find a particular row. So primary key should not be nulls, otherwise it will create a major problem with our database. A table can contain a null value other than the primary key field. Okay. Whatever it suggests that in the integrity value, so primary key attribute, particular attribute is the primary key, at that time that particular value of that primary key should not be null. But it may possible that primary key having the other attributes, so other attributes may possible they can be blank, but primary key can't. For example, I would like to explain with respect to this given table. There is an employee table having the employee ID, employee name, and salary. Suppose employee ID is 123, and this is the prime key. Employee ID is my prime key. So this employee ID can't keep as a blank. So it is going to be shown over here in the before the name of the Jackson having salary 27,000. The employee ID is blank. So this is not allowed. Second, a table contain a null value other than the primary key is valid. Okay. Suppose 164 having the employee name John. If this salary is not mentioned over here and it can be blank, so it will be the okay. So that can be okay, but here's the employee ID blank is not allowed. So it is called as the entity integrity constraint. Referential integrity constraint. So what happens in the referential integrity? So in the referential integrity, we need to take care of the foreign key and the primary key. When we are going to divide our data, or can be available our data in the two table, so at that time, the foreign key of the first table can be act as a primary key of the second table. So it is shown over here in the table 1 and table 2. And table 1 having the employee name, it is the employee ID actually, employee ID, name, age, and his department number. And his department number act as a foreign key over here. And that foreign key can be act as a primary key for the table 2. So in the table 1, there are 4 entries are shown over here. Whereas in the table 2, there are only 3 entries are shown. So this is not allowed. The entry number, department number 18, having the employee ID 3, having name John and age 27, that data is missing in the table 2. So this thing is not allowed in the referential integrity constraint, because foreign key is act as a primary key for the table number 2. So all the values available in the foreign key should be available in the primary key. So it is specified between the two tables. If the foreign key in the table 1 refers the primary key in the table 2, then every value of the foreign key in the table 1 must be null or be available in table 2. So that should be available in the table 2. It is called as the referential integrity constraint. Key constraint. So key, that means we can assign different keys such as the primary key, foreign key. So the keys are the entity set that is used to identify the entity within its entity set uniquely. So an entity set can have multiple keys. It may possible the entity set can have multiple keys, but out of each, one key will be a primary key. So you can assign a multiple key, but out of this multiple key, only one key can be the primary key. So a primary key can be contain a unique and null value in the relation table. That need to be understood. A primary key can contain a unique and null value in the relational table. I already suggest that the primary key should not having the null value. Primary key should not having the null value. but we can't put the null values. But we know that if we are going to put a null value over there, it can suggest, or we can suggest that can't put a null value because of the null value, it can affects on the other data available with respect to a particular row, and that row is not going to get identified. So it is going to suggest that the primary keys don't having the null value. So even given table, there are some key constraints. So ID, name, semester, and age are the attribute, out of which the ID 1002 is going to get repeat over here. So in the key constraint, and if you are giving a primary key over here, so in the primary key, you can't repeat the ID again, or you can't repeat the primary key. So this is going to be happen over here. This is called as the key constraint. So entity set can have multiple key, but out of which one key will be a primary key. So that primary key can't be get double. It should be a unique, or it is always unique. So in the database design, the relational data model was introduced by CF Code in 1970. It is the most widely used data model for the database design. The relational data model describes the word as the collection of interrelated relations. What is the relational data means? What? The collection of interrelated relational. So a relational data model involves the use of data tables that collects a group of the element into the relation. So this model work based on the idea that each table setup will be include a primary key or identifier. So that is available in the database design. Other table uses the identifier to provide the relational data links and the result. So identifier is normally provided the relational data and links, relational data links and the result. So there are many commercial relational database management system RDBMS are available, such as Oracle, IBM having DB2, Microsoft SQL Server. So these are the various types of the commercial relational database management system. There are some free as well as open source RDBMS, that is the relational database management systems as well, such as MySQL, MSQL, it is called as a mini SQL, and embedded Java DB, it is called as the Apache DB. So database administrators use structured query language. Normally, SQL can be used to retrieve data elements from the relational database. So to update a data, to create a data, to delete a data, insert some information. These are the certain operation that can be performed by using structured query language. So it is called as the SQL. So this is called as the referential language used for the retrieving data. So database design objective, while the terms database design is comes at that time, certain objective of this particular system has been considered. So these objectives are eliminate the data redundancy and ensure the data integrity and accuracy. These are the two main objectives of the database design. So to eliminate the data redundancy normally database design is going to perform. So same piece of data should not be stored in more than one places. So the data is not get common at another place. So duplicate data should not be there, because duplicate data not only waste, because the duplicate data will waste the storage space, also it leads to inconsistencies. So for that purpose, we need to eliminate the data redundancy, ensure data integrity and accuracy. We know that data integrity means that itself it suggests the accuracy. So it ensures the accuracy and consistency of the data over its entire life cycle. So on implementation and usage of any system with the store, process or retrieves data, that can be taken care by the database designing. So while we are going to use in database design, at that time there are certain features, but that feature is with respect to the good relational design. It may possible someone design a bad relational database design, but it is not accepted at all. So what are the features of the good relational design? It should be accurate. Data is stored just one, which eliminates the data duplication. Flexible. Complex queries are easy for users to carry out. It should be collaborative. Multiple users can be accessed the same database. It should be trusted. Relational database models are mature and well understood. It is secure. Data in the table with the relational database management system can be eliminated to allow the access by only particular users. Tabular structure or index file data. SQL DLL, that is data definition language can be supported. SQL DML, data manipulation language, also enhanced. So by using this all SQL DLL and DML, we can enhance the performance of the system. This is what the features of the good database design. How we can design a particular database design? So there are certain steps. So 4 steps are normally there. So first step is called as the relation and attributes. So the various table having the attributes and related to each other identified. So in this way we can maintain the relation and attributes. Primary key. So the attribute to set the attribute that uniquely identifying the record is assigned as the primary key. We know very well about the primary key. Relationship. The relationship between the various table are established with respect to the foreign key and the primary key. So that foreign key can be act as a primary for the next. It may possible the relationship 1-to-1 or 1-to-many or many-to-many can be possible. Normalization is the 4th step, is very important. So this is purpose of the optimizing a database structure. For the optimization, normalization is normally used. So the normalization simplifies the database design to avoid redundancy and confusion. So all these good features of the relational database design can be given by the normalization itself. There are various types of the normalization. First normal form, it is called as the F and F. Second normal form, S and F. Third normal form, Bayes code normal form, and fifth normal form, and so on. So these are the various normalization. So in detail, these different normalization forms can be seen in the next session. So this is what the good relational database design and what are the various steps. So thank you for attending the session. So in the today's session, we have seen the integrity constraint, or how the integrity is going to be useful. And then we have seen what are the good features as well as the design steps of relational database management system. Thank you. Thank you for attending the session. Thank you, everyone.